NDCG can look fine while the first result is wrong. ERR K makes top-heavy ranking failures much harder to miss. This is the pattern you'll be able to implement by the end, which evaluates top results with probabilistic rank checks and contrasts them with game-based scores. I'm Professor Pi, teaching Search and IR with simple Python. Search evaluation is all about that first impression. If the top result is wrong, people abandon the page and your metric should catch that. ERR K models users as probabilistic stoppers. Relevance grades become chances a user stops at a rank. That makes ERR very focused on the head, whereas NDCG spreads credit down the list. In practice, ERR helps surface catastrophic head swaps that a decent NDCG can hide. We'll convert relevance grades into per-rank stop chances, multiply those through the list, and produce a single score you can average over queries. The payoff is sensitivity to head failures. The trade-off is noise on tiny or coarse grade sets. We will build a small evaluator that maps judged grades into stopping probabilities, computes ERR at a prefix length, compares ERR to NDCG when a top document moves, aggregates across 2 queries, and finally flags surprising drops so you can triage quickly. Quick note, this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. We first need a tiny piece that converts graded relevance into the cascade stopping probabilities. That gives us the building block for ERR. This snippet turns the judged relevance grades into per-rank stop probabilities, so you can see the ERR browsing model directly. The list gains holds one query's graded relevance in rank order, and Gmax normalizes those grades into a saturation curve, so each grade becomes a stopping probability. The loop keeps a running p-continue, multiplies by each set prob to get the stop probs, and stores them. Because p-continue shrinks multiplicatively, a large gain early on soaks up most of the stopping mass, while weaker early grades leave more for the tail. The final print reports the rank 1 stop chance and the remaining examination budget, which confirms how a single excellent document can dominate attention. Now we want to fold those stop probabilities into the actual ERR definition. That gives us the expected reciprocal rank at a chosen cutoff. This example wraps the cascade math into an ERR K function that returns the expected reciprocal rank for any prefix k. The function accumulates error by blending the current rank stop probability with the reciprocal of that rank, while updating p-continue for later positions. Passing Gmax reuses the same normalization from the first snippet, so scores are comparable. After defining ERR at k, we call it with k3 to summarize the first 3 ranks. Extending k lets later documents contribute, but their effect drops off fast unless p-continue stays large. The printed ERR at 3 value gives the top weighted quality summary will contrast with NDCG. With ERR computed, we can test sensitivity. A quick mental experiment is to displace the top relevant document 1 rank down and watch ERR react. We want a comparison to NDCG on the same gain set. This code computes ERR and NDCG before and after swapping the head document to show how each metric responds. The array swap moves a grade 3 doc off the top, placing a grade 2 item first and pushing the weakest item back. We reuse ERR at k for ERR deltas and pre-compute the log discounts so both rankings share identical discounting for NDCG. The ideal list is used to normalize NDCG scores. Since only the head changed, ERR drops sharply while NDCG barely shifts, and the printed deltas quantify that divergence to show ERR catching a head failure NDCG misses. Single query checks are useful, but real evaluators need averages across queries. Next, we'll add a small aggregator to compute both metrics across a pair of queries and report mean gaps. This snippet adds an NDCG at K helper, so we can aggregate ERR and NDCG gaps cleanly across multiple queries. The helper sorts gains once to form the ideal, zips prefixes with log denominators, and returns a normalized NDCG without recomputing ranks repeatedly. We then define a second query in Q2 base and Q2 swap to broaden the test set and pack both scenarios into QS along with their grade caps. Generator expressions accumulate the per-query ERR and NDCG differences between baseline and challenger, and NVN averages those totals. The printed averages show that ERR still reports a sizable gap, while NDCG softens the discrepancy. Okay, averaged gaps point you where to look, but teams want actionable alerts. Now we turn per-query drops into a triage list you can inspect quickly. This example converts query-level gaps into alerts that mirror a triage workflow. Iterating over QS keeps query IDs with their baseline, challenger, and grade cap, so error at K and NDCG at K are applied consistently. For each query, we compute error gap and NDCG gap, then collect cases where errors drop exceeds alert threshold while NDCG hardly moves. The surviving tuples are error alerts, which we sort by severity so reviewers focus on the worst head failures. Adjusting alert threshold, or the NDCG filter, widens or narrows the watch list. The printed top ER alert shows which query to inspect first and how large the ERR drop is. This tiny pipeline maps directly to a review process. Run it regularly on judged queries, sort the alerts, and hand the top items to a human reviewer. If you have production logs, weight or prioritize queries by traffic instead of treating all equally. In short, ERR K turns relevance grades into stop probabilities, so it concentrates value at the very top. Use it when head exposure matters and you need to catch first-rank failures quickly. Just remember, it's sensitive to coarse grading and small judgment pools. Next step, scale this same pipeline to a larger judged corpus and add a timing check so you can compute ERR and NDCG at production speed. That way, you can monitor model changes and triage regressions automatically. If short, practical IR helps, subscribe and watch the IR videos.